This question is about convection. It says that the diagram shows how air moves near the coast on a warm day. So we've got the cool water here, we've got the sun here, and we've got warm land. And then we can see that the air is moving up above the warm land and then moving out across to the ocean and then falling back down and then being pushed back towards the warm land. And the question asks us to explain why air moves as shown on the diagram. Now there's 5 marks. Now convection is all about the movement of fluids, and fluids are liquids and gases. And that's because liquids and gases, the particles aren't fixed together in rows like they are in solids, they're free to move around. And because they can flow, which is where the name fluids comes from, warmer particles, or particles with more energy really, can move relative to the cooler particles, or the particles with less energy. Now, in order for there to be particles with more energy, there needs to be an energy source. And in our example here, the energy source is the sun. And the energy source of the sun is transferring energy to the air. So that's our first mark. The sun transfers energy to the air. Now, this causes the air above the land to get heated. So that's our second mark. The air heats up. Now, hot fluids, liquids or gases, they become less dense. And that's because if you imagine what's going on it's easier to think about it in terms of gases. If we had a relatively cool gas, then you would have some particles moving around quite slowly in random directions. And whatever they're in, they're going to be having some collisions. And if the collisions are between quite slow-moving particles, then they're going to be able to keep in quite a tight space. If you had some particles which are moving around in random directions but much, much faster, then every time they collide, they're going to move apart from one another more. And so what happens is that the particles spread out and they fill up more space. And so if we think about that sort of section of gas here compared to this section of gas here, we've got the cold, slow-moving, low-energy particles here, and then we've got the hot, high-energy, fast-moving particles here. And so they take up more space the hotter the air is. So this heating of the air causes the air to become less dense. And therefore, it rises. So the reasons that things sink is because they're more dense than whatever's surrounding them. The reason that something floats is because it's less dense than the things around them. So that's why a big boat needs to have lots and lots of space on the inside of it with air so that the overall object is less dense than the water that it's floating in. And the reason that a helium balloon floats is because helium is less dense than air. So we've got 4 marks so far, but we've only actually even talked about the fact that we've had energy transfer from the sun, it's caused the air around here to heat up, become less dense, therefore rise up, and now we've got to talk about what happens over here and why it turns into a cycle. So as it rises up, it's going to lose energy, and then it's going to cool down, and then it's going to cool and become more dense, and it's going to sink. Then the air cools, becomes more dense and sinks. Now notice you only get 1 mark for that because you talked about it cooling, becoming more dense and sinks. We're not going to get an extra mark because we've already got this idea that the air heats up, becomes less dense and therefore rises. So you're kind of saying the opposite here, which isn't enough to get 3 more marks, but it is enough to get 1 more mark. And then the final thing to say is that we've had this bit of air here get heated up, become less dense, rise up, and then it's lost energy, cooled back down, and sunk back down to the bottom. But why does this part here happen? Well, that's because you can't just have a vacuum here where you've got this section of air that's just been given some energy, become less dense, risen up. More air needs to come in to fill the gap. So then we can say that air moves in or across to fill the gap. Now part B asks us to explain how Brownian motion provides evidence that air is made of small particles. Now, Brownian motion was first discovered when they put some pollen grains on the surface of water and they looked at it under a microscope. So what they found was that these pollen grains, much like this diagram here, were jittering around in this random zigzag motion. And the reason that they found must be behind this was that they must be being moved around by some smaller invisible particles. And in that case, the smaller invisible particles were the water particles. Now, as microscopes became more powerful, they tried this with smoke and air. And in this case, they were able to look at the smoke particles. And again, the smoke particles were moving around in these random zigzag motions. And that was because they were being knocked about by the smaller invisible air particles. So to answer this question, you can give either example, but you've got to explain what you would see and the reason why it was happening. So we can see that if you look at pollen grains, on the surface of water, under a microscope, you would see random zigzag motion, and that is the description of Brownian motion. We've got 1 mark for mentioning pollen grains on the surface of water and 1 mark for talking about this random zigzag motion. And the final mark is for giving the reason behind this. This is because the smaller invisible water particles are colliding with the larger visible pollen grains or particles.